Okay, let's do that again. Okay, so this is what we have right now. Okay, I'm going to wait for all of you. If you already see this part, that's okay. But if not, I'm going to wait. Let me know if you're done with your thumbs, as usual. Thumbs up. Let me just put this one underneath. Okay. I forgot where is the thumbs up in this new. Hmm. Where is the reaction? I don't know where the reaction in my new full squeeze breakout room. I can't remember where it is. Okay. Anyway, so let me know if you're already done. If not, then just let me know also if I have to wait. Okay. Okay. Good. So where is the thumb in the screen, Arif?
In the React
I
uh,
don't have
of
React for some reason.
uh, uh,
So if I go down, there's there's
wait,
audio, video, participant, chat, share,
okay.
pause,
I
annotate,
will try to add to chat, sir.
Okay. Cannot find it.
Wait,
There is my. Yeah, I don't have that one for some reason. I don't have the effect. Mine is. Let me just screenshot what I have. Okay. Hmm. Screenshot. Wait. Let me just screenshot the whole thing. And then, okay. Okay, let's do Harris. Okay, let me go to rectangular selection. Zoom.
maybe there is in more option, I think.
Yeah, I don't. I cannot see it. See, this is what I have on my screen.
Oh,
Let me just chat. Where is my chat? Okay. Da, 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 da. Cancel. Where is my chat? Chat. So this is format file. Hide your computer. So this is what I have. Picture. See, this is what I have. Only that one. Cannot see it in my computer. But anyway, kind of strange, but that's okay. Okay, so now you have this. So let's start with a different one. So before we are using the what I call a generic Python, which means we don't have any specific modules or library. So tonight we're going to do a fast introduction of what Python can do. Now, one of the things, or nicest things about Python is that there are many libraries, or they call it modules, many library modules. Now, the first one is the one that is commonly used. It's called NumPy. Let's just do this. This is a library for numerical basic manipulation. So what we do, if you want to import a library, we can do this. Import NumPy. This is number library of Python as NP. What we are doing is this: we import NumPy as NP. So later on, we can call the function or the library as NP. Okay. So say for example, I want to have an array. For example, uh, this is what I have right now. I want to have this. And then if I can put, this is like a matrix. I want to create a matrix. The first row is 1, 2, 3. The second row is 4, 5, 6. The third row is this. Okay. So this is possible to do that. I'm just going to copy this code. Wait, copy, copy cell, and then I'll put it in the chat section. So if you want to copy and paste ECR using that one. So this is basically if you want to do some kind of matrix operation. You can add matrix, invert, find determinant, eigenvalues, and so on. So this is, you can do it this way, right? But I'm not going to go into this. It's just an example of what a NumPy can do. We're going to use NumPy in many things, but this is just, it's not interesting in my opinion. NumPy does lots of things behind our beyond other libraries of modules. So this is just an example, but there are more. So the way I teach my classes, I don't have to go through the details if it's not important. So this, we leave it as is. Okay. So right now, what can we do? Now we want to create, say, a random number. Import NumPy SNP. So for example, I want to create, say, a simulation of berat badan, for example, berat badan, right? It's equal NP. Now let's call random. Random is a function in NumPy. Random integer. The low is between 50 to the high is 100. Size, for example, 100. Okay. So I can print berat. So if I run this, then it will create numbers for you, random numbers for you from 50 to 100. Actually, 50 to 99. Usually when you have this, it starts from 50, and then this is the top level, but inclusive. Sorry, exclusive. The 100 is actually. So it's between 50 to 99. If I run it again, you'll see that the number will change here because it is a random number generator. So, for example, if you want to create simulation, I want to create a simulation of a set of people having the weights, the berat badan between 50 to 100, and I want to have like 100%. This is an example of we do it. The one that we use, the random, is using uniform distribution, but we can have like a curve, bell curve distribution. That's also possible with a different command. But this is just an example of what it is. Okay. So let me just see if I can have another. Hmm. Now I can also save this data. If I want to save this, I can save it. NP save text. Okay. I want to call in, say, berat.csv. Okay. That's the file name, and the variable that we want to do is berat. And then the format is what format, the numbering format is what we call %I. Okay. So I'll explain it to you later on. So this is, let me just copy this one again. Put it is in group chat. Okay. So this is an example of what we are going to do is we import NumPy as NP as you saw, and then you can play with it, the range between 50 to 100, and the size you can also change if you want to, like change the size into 300, for example, and it will generate a 300 number, see, for you. And it will be stored in a file called berat.csv. And then the format is fmt%1. It's basically, it says, okay, I want to save it in number integer format, bilangan bulat. Okay, now if you look into this, the folder, click the folder, and then you'll see this is a file. There's a file called berat.csv. You can download this. If you click, you can, download this, and it will be downloaded to your computer. If you like, to your download computer, so you can generate this and then use CSV, and then you'll export it here, and then you import it in your, say, spreadsheet, Excel, for example, right? You can do that. Okay. Okay. So this is what we can do. Ada pertanyaan? Is there a question? I'm going to. Uh, if you want to see the file also, if you double click the berat CSV, on the right side, you can see that it says 1 to 10 of 299 entries. So there are 300 entries. Okay. Oh, okay. The first one is this one because it treats this as a header. So there are actually 300. So it's 65, 80. So if you look this, it's 65, 80, 93, 65, 80, 93, 80. So it will be printed in a file like this, 65, 80, 93, 86. It's one number after another. Okay. Adakah pertanyaan? Question? Okay, good. If I can
Good, sir.
click again. Yeah, here. Yes, silakan. Ada pertanyaan?
Not yet, sir. Still following.
Okay, yeah. Now, this is good. We can generate this, but I want to see. I want to see because I cannot comprehend. I want to see the amount of data here. Okay, how do I do that now? Let's do another step is to sorry, we're going to go to the second library, which is Matplotlib. So let me just go to here and then type in Matplotlib. Let me just show you what Matplotlib. Okay. Matplotlib is a visualization for Python. It's basically a library if you want to visualization, if you want to have different kind of plots. So if you click on the plot types, you can see different kinds of plot. Okay, you can see you can have a plot like this, right? This scattered, bar, histogram, and so on and so forth. So if I click this, I can see, okay, this is the plot, and this is the example, the code to generate this plot. Okay. So this is an example of Matplotlib. And there are many examples, yeah, plot a different kind of, more complex plots. You can see, and there these are the examples, and you can see the codes how to generate this kind of plots. Okay, so you can have different kind like this. Okay, now let's go back to this. Okay, now let's view this data, and I want to see that. So what we do is we do import matplotlib pyplot. So we are only interested in Python plotting, and we call it as PLT because later on I'm going to use is PLT. Okay. So because we already run this part, now we have a plot histogram. Okay, histogram. The variable is called berat. Okay, and then plot show. If I run this, okay, this will show like this. So this is an example of our plot of this data. Okay. So this data we are plotting between 550 to 100, like when we ask it to generate a number between 50 to 100. So this is what it. So if I want to create a more what do you call it per number, we call it the bins, right? Bins is equals range from from 50 to 101, for example, right? If I run it again, so this one creates more kind of the spacing is more detailed. Okay. So this is the numbers that we generated. These numbers that we generated, if we plot them, it's like this. On the x-axis is the number, and on the y-axis is the number, the many times it appeared. So for example, 80, I don't know how many times here. Okay. Now, this is good enough, but if I want to change, I want different color, say color is called red, for example. I can do this, and it will be plotted into red color. If you click right, you can save this image. Okay. Now, I want to have, say, what do you call it? Legend, for example, or label to X and Y. Okay, so let's use this PLT X label, say berat or weight. Wait, the Y label is, what do you call it? Number of people. If I run it again, then it will show like this. There's a number of people, the y-axis, and then the weight is on the x-axis. Okay. So let me just copy this one again, and then put it in our chat again. So try that one. If you don't like the color, I can change it to sky blue, for example. It's more interesting. Okay. So this. Okay. So now, for me, it's easier to do plot this than to do it in Excel, for example. It's easier for me to do it through this kind of code, simple code, right? Using the sign code, and then I can plot it, can save it. Ada pertanyaan? Is there a question for this? So we've done two modules. One is NumPy, and then the other one is Matplotlib.
Sir, Harry speaking, sir.
Yes, there is.
Yeah. So, if I see, if I look this application, uh, this application when it works like Excel, sir.
Mm-hmm.
Yeah, like Excel,
Mm.
or different with Excel, sir.
This is different because, for example, right now the variable berat, for example, right, the berat, right, we generated the berat from random number. But for example, we can get the berat from say from the internet, from our production. So we can use a command to download this from another machine, right? Using the internet and then plot it right away. If you want to do that in Excel, we have to download it from whatever, right? Convert it to CSV and then open Excel, and then create macros to do this and that, right? But for this, once you have this, you can just run it and it will do the quote unquote
Okay.
magic behind it.
And this application will understand about the language as well. If I see the language, there are mixed language between Indonesia and then English, like berat badan and weight.
Oh,
But this application is understand. Is it correct?
no, this is just what we are with what that this is the way we
Oh,
just number put the the text. So the
okay.
Python itself does not understand the language, but Python itself has its own language kind of. And then the other stuff is just the one that we put the names ourselves,
Oh,
but Python does not understand this.
oh, understand. Yes,
Okay.
understand, sir. Thank you.
Okay. Ada lagi pertanyaan? Okay. Now, if you look into this, right? This is the berat itself is actually from this. Now we can do the same thing, but this time instead of using this, I can open it in open a file. So, for example, this is just the code is should be the same. So I can do this. Okay, from NumPy import generate from text. This is what I do if I want to. Sorry, again from txt. This is I want to read my data from a text file. Generate from txt. Remember, I have a file called berat.csv, right? This is a file that I have uploaded earlier or created. And then if I print my data, this is actually this is reading from my CSV, right? So this is basically reading the CSV, and you can see the data here. So the same thing using my data instead of berat, we can just do plot the same thing here, right? So now we can say, import again, import if you want, import matplotlib pyplot splt, and then we plot histogram again, right? My data, and then plt show, basically the same. But this one is we read it from a file. So if we run it again, if it's going to read, and then it will create the chat again for you. So once you have this, you can have a different kind of Brat CSV. So every day you can download, say, for example, Brat.csv from your production or from your back end, and then you plot this on a regular basis. You can show it on the screen. Or Brat, for example, you can also get it from the stock market, for example, the stock ticker. So you can create your own program to see the value of your stocks and so on, right? So this is possible. Oke, ada pertanyaan?
Not yet, sir.
Yes. Now, let's do another Matplotlib, another example. Now, what we want to do is just like this: so import matplotlib pyplot splt. Suppose I have two of variables. X1 is equal maybe 1, 2, 3, 4, 5, 6, 7, maybe. X2, sorry, the Y is equal to, I don't know, maybe 5. I'll do this random, okay? Something like this, right? I can plot this PLT plot uh, plot X1 against Y1, okay? And then I can do this PLT show. So I can do this. So it will, plot this. Okay. So if you want to do line plot instead of histogram, you can do this pie plot. Suppose I have two data. Maybe I have another data. For example, let me just copy this one first, and then so you can play with it. Okay. Let me just copy this one first. Copy, and then I'll put it in the chat room again. Okay. So you can copy paste into your code. Now, suppose I have another one. Say x2 is equal, I don't know, maybe 2, 3, 4, 5, 6, 7, 8, maybe just the y2 is equal, I don't know, maybe 1, 7, 8, 2, 3, 4, 1, maybe. And then I can plot, but this one is using scatter. X2, y2, okay? And then I can do this. And then you can see that the first one is line, and then the second one is scatter. Dot, dot, dot. Let's do this. Let's change the color for this one. Color is equal red, for example. Okay. So, I can have a different color. Okay. And then I can also create label. Let's label this first data, and then label the second one label second data, for example, right? And I can run. Okay, now I want to put a legend on the right side. Okay, PLT. Let's put the legend so that you can see there's a on the right side. Okay, there's a or sometimes they put it on the left side. So the red one is the first data. The second one, the dot is the second data. So you can do this. Okay, same thing. You can also put the X and Y. So you can say the X, I don't know, PLT X label time, for example, right? I don't know. And then and so on. You can also put the Y label, same thing. Okay. Then let's do the PLT Y label, say number of products, for example. And then say, okay, this is the time, this is number of product. Okay. So this is an example of another example of what do you call it? Python and Matplotlib. Okay. Adakah pertanyaan? Tidak ada? Oke.
Not sure. Still following.
Oke. Now, sekarang I'm going to create this one. I'm going to introduce a bit of statistic. This one is going to call this one called linear regression. Okay. Let's create a data first. Let's create a data import numpy as np. So we want to create a data. So we want to create a function like this: a multiplied x plus b, something like this. Like this is a line, right? Okay. So I want to say a is equal 0.25, for example. B is equal 0.75, and the number of points equal, maybe I'll try 10 points first. Okay. Now let's generate the data. Let's create a temporary variable first. X, let's say x point. Create an empty list, and then also y point. Let's create an empty list. This is basically empty. Now let's start creating the data for I, for I in range number of points, num points. Okay, let's do this. So it's what we are doing is 10 times. Oh, let's create x is equal. Let's create np random normal between 0 to 0.4, for example. Let's create x between 0 and to 0 point. Y is equal a multiplied by x plus b. Okay. Okay, and then now let's add this x point append append to the list, append x, and then y point append also, we add the y. Okay, now let's print this one first. Okay, okay, let's print x point, for example. If we run this basically creates a 10 number of x, right? And then let's just print y point. So what we are doing is we create x and y. This is x, this is y. X, y, x, y, x, y, x, y, x, y, x, y. Okay. So this just basically a random data. We can create 10. Now I want to plot it. Let's just plot. Let's plot. Let's see the data. Okay, let's visual. Okay, again we import matplotlib file plot splt. Okay, let's do this. Let's do plt plot x point against y point. Okay, and then plt show. Okay. So what we are doing is we're going to plot this. Okay. So this is basically the line, right? Okay. But sometimes I want to see the data as, not this line, but this one. Let's just do this with x. So basically, this is what I have. X, 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 the data, right? So I created 10 points. One, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 10 points. Okay. Now, this is not interesting. Let's create the y itself. Let's create some kind of randomness. Add randomness here. Let's add some kind of np random normal between, let's do that between 0.0 to 0.01. Okay, let's do this. So if you can see, sorry, normal. Oh, sorry. No, NP, salah, NP. Okay. So now our data is not in the straight line. Okay, let's generate the data 100 points instead of 10. So you can see, right, the number is something like this, right? This is, you consider this is like a kind of a line, but with some kind of noise into the Y. Let's generate this into 300 just to make it more data. So you can see. If I add more randomness to the Y, let's just this one 0.2, for example, right? It's going to create more deviation. So, okay. But this is, we can see that this is actually a line, right? This is actually a line. So if we get data from our manufacturing plant, for example, the data is something like this, then we want to find out the line. So that's what we call linear regression. Ya. Adakah pertanyaan? Ini dulu. Hello, let me just copy this one so you can run it on your Google Colab. Okay.
Sir,
Yeah.
I want to just make sure that this, if we want to, apa namanya, want to, sorry ya in bahasa guys,
Mm-mm.
jadi kalau misalnya seperti ini tuh sama kayak aplikasi SPSS gitu nggak sih, Sir?
Betul, betul. Kita
Oh,
mengenerate random data. Jadi kayak SPSS kita mengenerate data random antar segini. Nah, kita bisa generate seperti ini.
oh,
Tapi berarti kita harus belajar SPSS kan ya?
yeah, 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 yeah. So I think so we can compare that
Ya,
SPSS result and the Python result. Is it same or
ya,
not ya, Sir, ya?
ya.
Performance.
Harusnya sama. It has to be the
Okay.
same. They have to be the
Oh,
same.
okay.
But this one, instead of us learning another language, say SPSS, we just learn one language, Python, and then we can use it for all kinds of
Oh.
stuff.
Understand. So I think a lot of us for the thesis project using the SPSS or like SPSS system, sir. So we can use this application also, right?
Correct.
Hmm,
So
understand.
in the old days, we have to learn SPSS, and then if you want to do some kind of programming, we have to learn another language called R, right?
Oh,
That's also another language. We have to learn another
mhm.
language to do that, and then we have to learn whatever. We have to learn whatever. So we have to learn so many things. But this one, we only learn one language, Python. That's it.
Oh, interesting. Thank you,
So
sir.
you can do this, we can do that,
Mm, mm,
and if you can see that is this one is easy if you want to plot whatever. If you want to generate a random number, all you have to do is just one line. It will generate a random number for you. Okay.
mm.
Now, again, if you want to save this one to a file, you can save it. So np save txt. Okay, let's call this one line.csv. And the variable now, in the earlier example, the variable is only one, berat. But this one we have two variables, x points and 1 point, right? We want to save it x y x y x y x y in a file. So how do we do that? Now we have to create what we call a stack of column. Now this is what sometimes it is difficult to find out. How do we do it? The best bet is to find examples. So this, I know this because I've seen the example before. So I want to create x point, okay, and then y point, okay, y point, okay, okay. And then the format of the data, I want to save the number. Say format. Remember last time is %i because it's integer. So this time we want to save it I don't know, tiga angka di belakang koma lah, for example, right? So this is what we, three, F is floating point, dot three means 3 digit, okay? So if I run this, it will create the graph for you. It will create the data, but also it creates a file called line.csv. So if you click here, there's a file called line.csv. Okay? So the file is created. If you double click. Now the problem with this file is that this one x, y, x, y, x, y, but x and y, they're only separated with one space. Dipisahkan oleh spasi x dan y-nya. Saya nggak mau, I want to put comma in between x and y, x and y. Okay, so how do I do that? Let's just add this. Delimiter, okay, let's see. Let's just add. Delimiter is equal with, I want to have a comma in between. Okay. So let's run it again. So it will create again the line CSV, but this one, the line is delimited with comma. So when I open it, it knows that this is X and Y. So X, Y, X, Y, X, Y, X, Y. Okay. So let me just copy this code again. Let me just copy this one again. Okay. The addition is minor, only this line, right? So now we have a file called line.csv, okay, which is this one. Okay. Ada pertanyaan dulu tidak? Tidak ya? Oke ya. Now, forget about everything. Now, assuming I'm giving you a file called line.csv, find out the line, find out the line. Okay. Find out the line. What is the function of this line? Fungsinya apa? Y sama dengan AX plus B. A-nya berapa, B-nya berapa? What is the A and B? So, in that case, assuming I'm giving you a file. Okay, let's use this. Import numpy snp. Okay. Now I'm reading it, my CSV. My CSV is equal np generate. Again, generate from txt. I want to generate it line.csv from this file. And I know that the limiter is with comma. Okay. So if I print it, my CSV, okay, let's see. Let's run this. It should get that data. Oh, sorry. The limiter is equal, sorry. Okay, so this one, right? X, Y, X, Y, X, Y. So I have my CSV, okay? Now I want to find out the slope of the because I knew that okay, this is something like this, but I don't know the slope. Let me find the slope. Okay, now we know that we have x, y, x, y, x, y. So now I want to create a variable. This one is, I want to call in this one xp, this one is yp. How do I do that? I can do this xp, this one yp is equal. Now I want my variable is called my CSV. Now what I can do is there's a function called transpose. Transpose is actually will take x, y, x, y, x, y. Okay. So if I print xp, for example, this one will print the only the x version. Okay. So that's the x-axis. Okay. Now I have x, y, x, y, x, y. Now I want to find out the what we call a linear regression. To do that, you have to write a program basically. But instead of writing program, we call Python module. So right now there is a module again. Now from science Python, import statistic package. So I'm importing statistic package just like the SPSS package, right? No, I can say, instead of me doing that, I can do a linear regression. This is a package called linear regression. Okay. And I can see, okay, print the gradient, right? Gradient is the A. Okay. The A is equal gradient there. And then the interception, basically yang memotong garisnya, interception tuh yang B-nya ya kalau di dalam ini. B, intercept. Okay, gradient is that one. Let's just do this. Okay, let's just do this. This one called intercept. Okay, let's just print that one. Let's run it. So it says, okay, A itu adalah A is 0.2494, which is this one is 2.5, right? And then the interception is 0.75, right? So it is basically this one, right? 25 and 75. Okay. So if I'm giving you this file, I want you to find what is the A and B so that the equation, so the equation is y equal A times x plus B, right? So what is the A? A is that, B is that. Okay. So that's Ada pertanyaan nggak? So this is more like the statistic package SPSS. We can have a linear regression. So the nicest thing about that, we can call this linear regression using our data, and it will print the variables for you instead of you writing the code. Kalau dulu saya harus buat kodenya nih untuk linear regression. Nah, sekarang ini tidak perlu. Oke. Adakah pertanyaan? Now the last one. Now, udah mulai pusing ya. Now, the last one I'm going to teach you another statistic. That one is linear regression. Now, the last one is k-means clustering. So, but before we do that, let's find YouTube. Let's see k-means clustering. Let's find a tutorial. There is a nice tutorial called. How come my YouTube is very slow? What's going on? My YouTube. Okay, come on, YouTube. Okay, let's K means clustering. Okay, so there is a tutorial on K mean clustering. Okay, let's do this. Sorry, iklan dulu. Okay, let's do this.
StatQuest, StatQuest, StatQuest.
Ada suaranya kan ya?
Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about k-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for k. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1. Select the number of clusters you want to identify in your data. This is the k in k-means clustering. In this case, we'll select k equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for k, but we'll talk about that later. Step 2. Randomly select 3 distinct data points. These are the initial clusters. Step 3. Measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4. Assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to Step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster, using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The k-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since k-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, K-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall, so it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for K? With this data, it's obvious that we should set K to 3, but other times it is not so clear. One way to decide is to just try different values for K.
What if I told you that you can instantly create pro-level chords and progressions without knowing any music theory?
Okay.
We'll start with K equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try K equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the two clusters to K equals 1. Now try K equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the three clusters to K equals 2. Now try K equals 4. The total variation within each cluster is less than when K equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before, and when there is only 1 point per cluster, the variation equals 0. However, if we plot the reduction in variance per value for K, there is a huge reduction in variation with K equals 3, but after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick K by finding the elbow in the plot. Question: how is K-means clustering different from hierarchical clustering? K-means clustering specifically tries to put the data into the number of clusters you tell it to. Hierarchical clustering just tells you, pairwise, what two things are most similar. Question: what if our data isn't plotted on a number line? Just like before, you pick 3 random points. And we use the Euclidean distance. In 2 dimensions, the Euclidean distance is the same thing as the Pythagorean theorem. Then, just like before, we assign the point to the nearest cluster. And just like before, we then calculate the center of each cluster and recluster. Bam! Although this looks good, the computer doesn't know that until it does the clustering a few more times. Question: what if my data is a heat map? Well, if we just have 2 samples, we can rename them X and Y. And we can then plot the data in an XY graph. Then we can cluster just like before. Note: we don't actually need to plot the data in order to cluster it. We just need to calculate the distances between things. When we have 2 samples, or 2 axes, the Euclidean distance is the square root of x squared plus y squared. When we have 3 samples, or 3 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared. And when we have 4 samples, or 4 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared plus a squared, etc., etc., etc. Hooray! We've made it to the end of another exciting stat quest. If you like this stat quest and want to see more, please subscribe. And if you want to support stat quest,
Okay, let me stop that one. Okay, let's go back to our problems. Okay, now assuming now let's try let's share again my where's my Python. Okay, suppose I have a file called cluster. Okay, let me just upload this file. I'm just going to upload. Where's my cluster? Let's just do desktop. Where's my cluster? I think I have cluster. No, booty.
Already before that, sir. Already
Okay.
have cluster.
Oh, okay. Already there, right? Okay. Now I'm going to send you a file called cluster in the chat section. I'll send you the file here. Wait, where is my file? Wait, my upload file from my computer. Let's just upload it and I call it cluster, this one, okay? Okay, so now you have a file called cluster. Now you have to upload your cluster to this. So just use this up sign and then you can upload the cluster. So it's going to be there. Now let's try viewing the cluster. Okay, let's do the code. Okay. I want to see the cluster. Okay. Now this time I'm going to use another library called pandas. Okay, this is panda, just like panda. Okay, hang on a second. Let's just start import pandas SPD. So this is a panda library. A panda is another module, which is what we're going to do. We're going to treat that cluster as just like spreadsheet, just like Excel. Okay. Now let's read our cluster. df is equal panda read CSV. Okay. And we're going to use cluster.csv. That's the name of this file. And then header, no, none. Header none means if you look into this CSV file, okay, let's just double click. You see that the CSV file, there's the XY, 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 but there's no header. Sometimes you have a header in the name of the file, okay? So this one doesn't have header, so I'll say no header, okay? So I can print df. Okay. If I do this, you can see that, So this is, you can see that there are two columns. This is the column, first column, second column. And then these are the rows. This is more like a spreadsheet, just like Excel, right? So this is column and row. So I'm reading the file. The file is called cluster.csv, but I have two column and then 300 rows. 300 rows. 303 rows. Okay, now let's rename the column. Let's rename the column df. Let's name the first column. Let's name the first column columns. Columns equal. Now let's rename it. The first one, let's call it X. And then the second one, let's call it Y. Okay. If I run it again, so basically it's just a renaming of the column instead of 0, 1. So we know the column X and then column Y. We can rename it whatever we want, right? Okay, now I want to plot this, what it looks like. Okay, the same thing. Okay, let's do this. Import matplot. Okay, let me just do this and copy it first to you. So you can do this. Chat. Okay, I'll send it to you so you can follow. But you have to upload your cluster CSV first, right? Into this. Okay. Now import matplotlib pyplot as plt, right? As usual. Now I want to plot it. Okay. df. So the data frame or data, they call it data. Plot. I want to do plot scatter plot. Okay. What we want, the x variable is column x. The name is the same. The y value is the column number y. Okay, let's do this. plt show. Okay, I don't need to print df. Okay, let's just do this. Okay, so this is what it looks like. The cluster is something like this, the data. Okay. This is the CSV data, the XY. This is, for example, you own a restaurant. and this is the typical coordinate of your buyer. For example, the buyer from Shopee Food or Gojek, GoFood or GrabFood, and these are the people who are ordering from your store. So you can see, oh, okay, the people are from three distinct locations, right? So if I have more money, where should I put my store? So I put my store closer to this area, right? To this area. So what I'm looking at this is these three clusters, and I want to find the centroid, the central of this cluster. So how do I do that? How do I do that? So I can write a program. Remember, just like what's in the video, right? The start class video. So you have to write a program to find the distance between this and that and this and that. Now, in Python, all you have to do is, again, import a library. So instead of us writing the code, I can import. There is a library called sklearn. This is a machine learning library. I want to find the clustering library, cluster. I want to import a library called k-means. Remember last time it's called k-means clustering, right? The K means big with B, big K with M. Okay. Now, let's see our data. The result is KM. It's equal K means. So I want to see the clusters. Sorry, the number of cluster. Number of cluster is equal 3. Okay. There are 3 cluster. And I want to use the data, fit the data of the F. Okay. So now, once we put this, the KM is actually the result of that algorithm, the policing, whatever, right? Now I know the centroids. The centroids, okay, let's find the centroids is basically this variable cluster centers. How do I know this? Because I look at the example. Again, you don't need to memorize this, just find this as an example. Okay, let's just print centroids. Right. Oh, sklearn. Oh, sorry, from. Okay, let's do this. So now I know the centroids are in this 3 section. But that's not great. Let me just copy this one again, and I'll send it to you in the chat section. Okay. Okay. So basically, I know the centroids. There are 3 centroids, 3.4 and 2.3. So it's somewhere 3.3. It's somewhere here, right? But I want to see it. So I don't want it. I don't want to see the number, but I want to see it in the plot. Okay. So now let's do a different kind of plotting. Okay. So now instead of this plotting the scattered, I want to do different kind of plotting. Okay. Remember when we do have this, everything is in one color, right? I want to have different colors for different cluster. Okay, let's do this. PLT scattered, similar to that one. But now I want to do an exact X and Y. The column X as the X, and then the column Y. I can also X and Y, okay? This is the data that I want to plot, okay, from that data frame, okay? So, okay, sorry, I'm missing the column. I want to plot X against Y, okay? Now, if I do this, it will be blue as usual, but I want to say the color. The color is the label. The label. So the color, so the label, see, for example, the cluster is label, convert this label into, this basic, don't worry about this. No need to memorize this, just copy and paste. Load, I think. Okay, let's just do this. Then penalty. So let me just show. Let's just do this. Can I do this? Let's just see. Let's just do this. Boom. Yeah, so it will plot it with different colors. Now I want to put the centroid. Okay, now let's just put the centroid plot. the scatter, but I want to print the centroids because there are three centroids from the beginning until the end. This is the array, right? The centroids. Okay. Centroid 1 until centroids, the rest of the centroid, and then let's say the color is equal red because I want it to have different color. Okay, let's do this. So you can see the centroids are there. Okay. So this is first cluster, second cluster. So that center is 4.3, whatever, right? 4.3. That's that one. Now I can also this is the size of the color of these bubbles. I want to make it a bit fancy. Let's do this. Alpha, it's go 0.4. So this will make it kind of you know fancy. So it's kind of transparent. If you have something on top of that, then it's becoming on top of that. I can change the circle. Let's just circle. The size of the circle is 50 points. Yeah, let's do this. I can change it again. Let's see, this one is 60. Make it bigger, the circle. Okay. So you can see this one is bigger, the circle. I can make it also 70. Let's do the 70.
Sir,
Yes.
what if the centroid is in different color? Each
Now,
the scatter.
yeah. Let me see. I can plot the first centroid using different color, right? How do I do that? Yeah, it's possible, but I have to think. I can put the centroid XY
So it's a
plot.
C. It's label as type of float, right? So you can change it in C equals
Yeah,
to labels, and it's a float like the
let's do
plot
that.
scatter.
Let's do this. Okay, let's just do this. Okay, let's do this. But that one is the labels of the KM. Okay, let's just do this. Just like the boss, right? Let's do this. This one is going to be the same as the cannot. Invalid RGA. The colors cannot do that. Okay.
Or if we have a different color, so it's called float, sir. Or float, it's mean something, sir.
A float is this is a floating type because if we let's just do this. Let's just print off. Okay, let's just do
Or
this.
maybe the C is equal to, oh, no.
Print. Okay, print this, right? Let's see, print. Okay, what is this? Okay, so okay, the centroid is this label as float. So the label, okay, let's just do this. The C equal K dot labels as type float. So this is basically okay. So because okay. So this is what it does. The first one is going to be first, second, 3. So okay. So now the centroid, we're going to do the same again, but the color now, not the labels, but the centroids. Let's say the centroid number 1, centroid number 2. Let's just okay. Okay, let's do this. I know that one, so now I want to print centroids. I want centroid 1 to be different color, right? Okay, let's see, do this. Okay, let's just remove that one. Let's just run it again. Centroid 1. Oh, okay. So this is the X and Y. X, 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 Y, Y, Y. Okay. Okay, hang on a second. Let me just print centroid one. Centroid. This is this. Okay, I can do this. I can put one by one. So I can print centroid 0.0. Let's just 0.0 and let's just do this. Centroid 1.1. Say sorry, 0.1. Let's just do this. Let me just to make sure. Okay, sorry, centroids using S. Let's just print. Okay, this one and that one. Oh, okay, I can do this. 1 1. PLT scatter. Now let's do this centroid. This and that one. Only X and Y. Okay. And then the color is, say, for example, one is, I don't know, blue, for example, right? And then let's do the centroid 2. This is the first one. This is the second one. And then the third one. Okay, good. Let's do this. This is red, for example. Red. And then this one is green. Let's do this. Boom. Shoot. Okay, so you have different colors there. Okay.
I understand, sir.
Eh?
Understand.
Okay, so now let's just remove this one. Okay. Let's move this one. Okay. So the first one is actually plotting the X and Y, but the label, the color, it depends on the label of the point. So for example, it is plotting this and then the label is 1. Okay. And then this one, the label is 1. And then this one is the label is 2. The label is 3. So it's basically using 1, 2, 3 as a different color. Okay. And then this for this one centroid, I'm going to put the first centroid using blue, second red, green. So that, but this one is only 1 point. But the first one, this one, the scatter DF, it is an array of whatever you have the points kind of. Okay. Okay. Let me just copy this one. Put it in your chat. Okay. So this is just an example of what we are doing. Okay. And the last one. Let's do the last one. Let's do the last one. I have also. This one is a bit different. I want to have, let's see. Okay. So I want to have another one, but this one is just an example. Also, this one is plat number. Okay, let's just do this. Let me just open the chat and then send a file to your computer. This is called platnumber.csv. Okay. And then I also upload it to mine. Let's upload platnumber.csv. Okay. So I have a file called platnumber.csv, which is basically like this. License plate, the owner, the maker of the car, the model. So D1234 XYZ, owner Budi, maker Ferrari, model F1. This one is B144AR. If you read it, this is biar, this is dasar, this is daging, this is aing. So these are the owners and makers. So I'm going to read this. Okay. I'll read this plat number. Okay, let's do this. Let's do this. Okay, wait. So I can also import pandas SPD, for example, right? So I can open a data frame PD read CSV plat, sorry, plat number dot CSV. Okay, and then I can print DF. So print DF. So to read a CSV using Panda, all you have to do is this. So if you open Platnomer and you read it, Panda is just like this. So it's just like Excel exactly. So this is the first row, second row, third row, fourth row, fifth row, and then the title of the column, it's already there. Okay. And then you can also, for example, I want to sort the value based on the makers, for example. Let's just sort. dfx is df sort based on whatever value of the, say, the maker. Column is called maker. Let's print df. Print dfx. Okay, let's just run it again. Oh, sorry. Sort values. S. Okay. So the first one, the original data, and then the second list is actually already sorted based on the maker. Ferrari, Tesla, Toyota. Yeah, so you can see, you can have it sorted. You can make column. So this is you can do all kinds of column manipulations, row manipulation, just like you're doing it in Excel, but you can program it. Okay. So for example, I want to see the column, I don't want to see. I want to change the order. New DF, for example, the old DF. But now I want to change the order. Say plate first, plate, and then I want to have it. The second one, maker. Sorry, I want to have plate, and then I want to have maker. It has to be the same maker, maker, and then model, and then the last one is the owner. Okay, let's print. Yeah. Okay. So you see the order is a bit different. Plate, maker, model, and owner. Okay. I can sort it based on two columns and so on and so forth. So this is basically column and rows manipulation, just like what you're doing in Excel. So you can get this data right now. I'm getting the data from reading from CSV, but you can get the data from on the internet, from your production, from your manufacturing plant, and so on. So that's what we are going to do tonight. Ada pertanyaan?
Not yet, sir.
Okay. So let me recap. Let me recap what we learned about Python. So what Python is a generic programming language. You can do all kinds of stuff, right? Well, in the first session 2 weeks ago, we learned generic Python programming. Now today or tonight we are learning. We learn how to use Python libraries or modules. They call it modules. The first one that we learned is NumPy, all kinds of numbering. There's kind of number. If it's related to number, NumPy is the best thing. Second, we have Matplotlib to do some kind of visualization using Python. There are all kinds of manipulation with image and so on and so forth with graphics basically. Okay. And then the third one, we are using pandas to read this, like pandas to read data into more like columns and rows, just like spreadsheets. So we call it data frame. We use pandas to read data frame, and using those three libraries, we can do all kinds of manipulations. Of course, we have specific libraries. For example, remember we have this k-means clustering. It will identify the centroids of the clustering by using this library, k-means library. The same thing if you are doing linear regression. If you want to find this one, this is a straight line, but sometimes you have a curve fitting. Sometimes it's not a straight line. Sometimes exponential or whatever. You can also use statistic libraries. This one is from this one, science Python, all kinds of SciPy. So you can also look into say SciPy. So you can have like This one is all kinds of algorithms in Python. Okay, and then also we use sklearn. Okay, sklearn is a Python science kit. Okay, so this is now. This is remember we use clustering using this, but we can do also regression. So this is we can also do classification, more complex stuff using science kit learning. Okay. So there are many libraries like this, special purpose libraries built in Python. So that's basically what I'm going to tell you or teach you about Python. So now you are a Python programmer. That's it. Question, silahkan kalau ada yang mau ditanya.